Hello guys, and today we're going to talk about scientific notation. Now scientific notation should be a familiar terminology in both chemist and math world. It's a simple form to express larger or smaller numbers. Now, the traditional writing notation or traditional format for writing numbers follows that of the terminology of either decimal notation or it follows that of conventional notation. Now, decimal and conventional notation refer just to your normal way of writing numbers. You got 365 days in a year. That's decimal notation. Conventional, 186,500. That's conventional. But today I'm going to talk to you about this notion of what scientific notation is used for. Well, to do that, I want to start off by giving kind of a math recap and make sure that you understand that 10 times 10 times 10 is equal to 1,000. I hope that you know that. You should also know that this is also equal to 10 to the third. So 10 to the third is equal to 1,000, which is also equal to 10 times 10 times 10. So what happens if I'm asking you to express a smaller number? Say something that's equal to 10 to the negative third. Well, 10 to the negative third is a little bit different. When it's negative, you know that the value of the number is actually less than 1. And so that is the expression for 10 to the negative 1/3. That is also the same as saying 1 over 10 times 1 over 10 times 1 over 10. All of those are equal. So the interesting thing about this is that there's a parallel between the exponent and the number of zeros, or placeholders before the last number, if you will. Here you see there are 3 numbers that go with that. If you go here from the decimal point, it's 1, 2, 3. But that's 3 to the right, meaning negative. And then for positive, it's 3 to the left. So all of those things are very important in terms of conceptual understanding what scientific notation is and what it does. So hopefully I'll be able to give you classic examples of where you could actually include these principles in expressing a number in scientific notation. Now, if you didn't know, scientific notation combines the ability to convert those numbers, featuring numbers that are multiples of 10, or other numbers that may benefit from being multiples of 10, and you can take those numbers and convert them into shortened forms of the same number. So to do this, I want to start off with kind of just a generic example of a very large number. Here you have 602, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Is that other 0 visible? Let's see. Okay. So this is a pretty large number. Let's go ahead and see if we can express it in scientific notation. Now, from the rules that I talked to you about with these larger numbers, you always start from the decimal point. And if you were starting from the decimal point, you would count from the decimal point the number of humps. So this would be like 3 humps here, another 3 humps here, another 3 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 here, and 1, 2 there, leading up to that point. So if you're a math person, I'm a 3, 6, 9, 12, 15, 18, 21, 22, 23. So that is 23 little humps going from the decimal point 0 to the spot located right before the last number on the left. So what you do is you combine them. You say 6.02, and that is your number, and you multiply that by 10 to the 23rd. Now, obviously, you see where the 23rd comes from because we've counted those humps starting from the decimal point all the way to the left side where the last number is, and we counted up to 23. There are 23 of these. You can likewise start from this location and go the same direction that way to the decimal point, and it'd still be a 23-point value. Once you have that, and you have your 6.02, you have your scientific notation. That is your scientific notation of that number. Now, let's do another example just to see if we can understand kind of the notion behind this way of writing the numbers. Now, let's take the number 47,760, and we're going to convert that to scientific notation. Now, of course, you always want to start with your non-zero numbers on the left. Starting from the last number on the left, and putting a spot between that and the number right to the right of it. 1, 2, 3, 4. You have 4 numbers. Now, because this is greater than 1, you know that your exponent is positive. What you also know is that 4 is the last number to the furthest left, and so the last non-zero number on the furthest left, so you take 4.776, and that is your scientific notation. But that covers only 1/2. That just covers just the sides of the equations where you have numbers that are greater than 1. But what about when you have numbers that are possibly less than 1? Well, I'm going to show you that. And judging from your knowledge of mathematical and algebraic manipulation, you should be able to kind of express these guys using this. So let's go ahead and get this board cleaned off. And we'll do an example. So we're going to take a large number. And we'll make this large number not large, but long. All right. This number is obviously less than 1. It's a very relatively small number. Now, similar to what we did before, you take the numbers, the first group of non-zero numbers, and you can use those. You bring those down, and you put your decimal point right in front of, or in the middle of, the first non-zero number to the right and the number that precedes it or follows it. So you put the decimal point, and now we're going to multiply that by 10 just like we did before. Now with this, we take the decimal point like we did before, and counting to the right, we go 1, 2, 3, 4, 5, and 6. 6 being the middle between the first non-digit number and the number that follows it. So 1, 2, 3, 4, 5, 6. You can verify it this way, you can verify it that way. And you know that it's a 6, but because it is less than 1, that is a negative 6. Now I've introduced you to the notion of going from decimal or conventional notation to scientific notation, but now we want to see if we can express these answers in conventional notation if given the number in scientific notation, i.e., let's take a number 111 times 10 to the negative third power. Now, first things first, I know that my 111 is somewhere in here. I also know that there is a decimal point somewhere here on the left-hand side because of this negative 3 number right here. Now, what we need to find out is how many spots we need to travel to the right and plug and play. So doing that, we take our decimal point and we go 1, 2, and 3. 3 being the spot between the furthest left and the one right next to it in that spot. And so after that, you put a 0 here, a 0 here. And so what that represents is your number of 1, 1, 2, there, that, and that. So you end up with it going to the right, and that's your answer. So let's give another example and see if we can convert that guy with a larger number that's greater than that. 3.98 times 10 to the 4th. Now, that should be easy. You remove the decimal point first, and you know that from this point between 3 and 8, you have 4 spots. So 1, 2, 3, 4. And that's your decimal point. Likewise, you can go on the top, 1, 2, 3, 4, and that covers your spots. So now you know that you need to input these zeros to accommodate that. And that is your number. Sounds easy enough, I think. Well, I hope that I've showed you and introduced you to the concept of scientific notation. One special caveat that I need to throw out there is that you should know that whenever you see 10 to the 0, it is always equal to 1. So that might be very useful when you're trying to express a number like 3.0 in scientific notation, which in this case will be counterintuitive, because 3.0 is the same as 3.0 times 10 to the 0. So, ta-ta for now, and